Hello. Hello, hi everyone. Those of you who can turn on the cameras, please turn on your cameras. I would want everyone to turn on their cameras. Okay, this is a GCSE live class for Year 11 students mainly, yeah. But I can see some of the Year 10 students have also joined. That's great, that's great. So everybody, please turn on your cameras. Come on, this is a live class for, doing the important topics for your GCSEs and all that stuff. Now this is being streamed on YouTube as well, right? So for all the people who are watching us for the first time and who are new over here, I would just like to give you a quick introduction about our platform. That is our platform GLECTA. We are dealing with online studies. We provide online classes and they are on a daily basis. So if you want to just sit at your home and take classes without really stepping outside, definitely this one is for you. And it's for all the subjects, be it chemistry, biology, physics, and for all the levels as well, like year 1, year 2, or year 12, year 13. We provide classes for all GCSEs, A-levels, SATs, KS3, 11+ exams, all of it. And apart from the classes that I'm talking about, there are notes and assignments which are uploaded on the website as well. So in case you miss out any class, the recorded lesson would be there on the website, which is www.gelecta.com, and your assignments and tests would be given on Google Classroom, right? And for coming to today's part, that what we are going to do today, for today I've taken up a few topics, like these are your grade 7, grade 8, grade 9 topics. So those of you who are aiming for the higher grades, of course, these are a few important topics, and I know that these are the kinds of topics that most of the people struggle with, like circle theorems. Ask anybody what topic are you struggling with, the first thing that they would be saying is circle theorems. So alright, I thought, okay, let's take up circle theorems then accordingly. And then there are proof related questions which are grade 8, grade 9 again. So how we can prove the circle theorems, then the concept of perpendicular lines, equations of tangents, all these topics that what we are going to do. Now I would want you guys to be active on text. I cannot unmute you guys for every thing. Although if you have any doubts, I would suggest that you see an option on Zoom to raise your hand, right? So you can raise your hand over there even without turning on the camera, right? I can see that all of my students are feeling shy suddenly for turning on their camera, but never mind. So you can just raise your hand in general over there, and if you want to speak something, if you have any doubt, you can ask me accordingly. I'll unmute you from my end and then you would be able to speak up. Alright. So also, if you're understanding, not understanding, keep giving me a thumbs up and a thumbs down if you're not understanding in any case, which won't be that case. Of course, you'll understand everything. So starting with the very, very basics, starting from circle theorems. You know what is a circle? A round shape. Right, that's circle. Now there are certain properties which are related to circles that you need to have in your mind. There are these 9 properties that we are going to discuss, and on the basis of these 9 properties there are questions that are asked. Now I can see on YouTube that Advit is there. Hi Advit, finally you are there. I can see you did not go to the gym. That's great. Advit, I can see that you are joined on YouTube. So if possible, can you join on the Zoom link over there? Over there you'll be able to speak up as well. Instead of just typing and texting, you'll have an option to speak as well. In the comment section, you'll see the Zoom link that would be provided to you. So the meeting ID and the passcode would be posted in the comment section over there. So you can just click on that, and then you can join in over on the Zoom session. Alright, so I would want to call all the people watching on YouTube to come on the Zoom session as well. The link is there in the comment section, Advert. You can just see for it. Alright, okay, starting from circle theorems, starting from number 1. Tangent and radius meet at 90 degrees. Now first of all, what is a tangent? A straight line which passes through the circle at only one single point, like there is only one point of intersection, that's when we say that we are talking about tangent. Now an important property, that radius and tangent are always perpendicular. Now how do I remember these kinds of property? With simple letters, L, right? And L makes a 90-degree angle, right? So wherever you see this kind of L, like you see on the top of the screen, this is an L which is being formed either ways, right? So that's a tangent meeting a radius, right? Then the next one, whenever we are drawing a circle, over here, this is my radius, this is my radius. And in a circle, the radii are always equal, right? So inside this orangish triangle that you see inside, that forms an isosceles triangle, right? So whenever we have two radii, we always form isosceles triangles with those two radii. Although that's not a property, technically, that's not a theorem, that's just a property you can say that we are using. Then the number 4 over here, that is angle at the center is twice the angle at the circumference. Now angle at the center that is made over here, if in the center I'm making angle of 80 degrees. So if I go on any other point on the circumference, like over here, anywhere on the circumference, so that would always be half of whatever angle is made at the center. So this would also be A. If I take any other point, like if I'm taking this point, I'm drawing this, right? Although my drawing skills aren't really great, you guys are already aware of that by now, I'm sure about that. So this angle is also half of the angle at the center. At the center we have 2A, so now we have angle A over here, right? Then coming to the next part, see, I'm going through these properties very quickly so that we can focus on the questions. Angle in a semicircle. Now you know a semicircle is formed with the help of a diameter. Now understand the logic also behind this, that why am I saying that the angle at the center is, angle in a semicircle is 90 degrees. You're drawing a straight line over here. This is a straight line, right? On this straight line, the angle that is made at the center, that is 180 degrees, right? And we just discussed a property earlier over here that angle on the circumference is half of angle at the center. So if in the center I have 180 degrees angle, then on the circumference I would have a half of 180, which is 90. Now an important property, that is whenever in the question they are saying that, okay, show that this is not the diameter, right? Whenever they are asking you to prove that this is not the diameter, in that case what you are supposed to do, show that the angle formed is not 90. You will have these kinds of questions on your GCSE exams, in your final exams. There are a lot of past year paper questions that I'll be showing you, in which they are like that, okay, prove that this is not the diameter. So for that, the only way that we are going to do this is by showing that it does not form an angle of 90 degrees on the circumference. That's what we do. Alright, I can see a lot of people have joined again over here, like new people have also joined. I can see Adel is there, Ryan, Sam, and Vibhu is there. If you guys can turn on your cameras, please, that would be great if you guys can turn on your camera. I can see only 1 or 2 people have done it, like only one actually. Abdul, kudos to you. Yeah. Right. Abdul is always on time and always turns on his camera. I can see Ryan is also there. Ryan usually turns on his camera. Ryan, what happened? Why are you not turning on your camera? Feeling shy today? Okay, there is Ryan raising his hand. Okay, you can speak up as well. Okay, Ryan wants to speak up, I think. So I'll have to unmute you from my end. 1 second, let me just see. So Ryan, do you want to speak up? Like, I'm just asking you to unmute here. Now, do you want to...
Yeah, miss, it's because it's a Saturday and I look like a mess right now. That's why.
No, Ryan, it's okay. You know what? You should be comfortable with yourself. That's one thing that I always say.
It's not okay.
Okay, if you not feel comfortable, it's all right. It's completely your choice. But I would say you should feel comfortable with yourself in a way that even if you're laying on bed, then you should be comfortable. Even if you're like going out and you're dressed up, then also you should be comfortable. It's like all about feeling comfortable. That's it. That's all. That's what I always say. So never mind, coming back over here to circle theorems right now. Over here, when we talk about angles in same segment are equal. Now see, the properties are easy to understand, not a problem. Like if I'm talking about segment, over here at point A and at point B, you see these are 2 points. How do we learn or how do we understand these kinds of properties? Over here, you see this line, this chord, right? Now this chord subtends an angle. It makes an angle at point B and it makes an angle at point A, right? So that's what we are saying. The angles that would be made on the circumference by the same line or by the same chord, they would always be equal. That's what we are saying. Now, how do we look for it in the question? Because circle theorems are easy to understand, but when it comes to questions, that's when we face a little difficulty, okay, that, you know, we are unable to identify which circle theorem would be used over there. So I'll tell you a simple way. It's like a couple name that you're going to see for M and X. So it's like this, an M and a mixed kind of X, like there is a cross and there is this like an M which is being formed. So whenever you see something like this, sorry, so whenever you see something like this, that's when you're going to say that, okay, the angles that are made on this M side, like these M that I'm forming, the angle over here and the angle over here, that's when we are going to say that the angles in the same segment that are formed are equal. That's what we are mainly talking about, right? Then coming to these kinds of important questions, this is an important one, the proof kind of question, grade 9. And the most important part of the proof of circle theorems, they say in the question, you must not use any circle theorem. Now, how do we prove a circle theorem without using circle theorems? So mainly you will have to use circle properties, not circle theorems. I want to work out, or I have to show the angle ABC is 90 degrees, this one. Now, I know most of you would say that, okay, we just did that angles in a semicircle, that's 90 degrees, right? So you would say, okay, miss, over here we have 180 degrees. So by using the circle theorem, but again, using the circle theorem, I do not have to use circle theorem. I cannot directly say that, okay, it will be half of 180. So no, I'm not going to do this. So what I'm going to do over here is draw triangles, see if I can use any properties accordingly. Let me connect O and B. I'm trying to draw a straight line. Oh, voila. Yeah, done. So now over here, I need to work on these angles, these 2 angles. Let's say this is X and this is Y. Now, if you see a triangle, that is triangle AOB. AO is the radius. OB is the radius. 2 radii always form an isosceles triangle, right? So over here, if this is an isosceles triangle, listen to me very carefully. If this triangle is an isosceles triangle, then this angle over here, that's going to be X again, because angles in an isosceles triangle, 2 angles are also equal, right? That's what we have. Then, similarly, if you see triangle BOC, both of these would form an isosceles triangle, right? BO, that is also the radius. OC, this is also the radius. By that logic, I would say, okay, this angle C should be equal to Y, right? That's what we have over here. So now triangle AOB, triangle BOC, we have got the values. Now what we can do is, we can work on the missing angle, that is like angle AOB. Now, if I want to work on angle AOB, you have the other 2 angles in that triangle, that is X and X. So, 180 take away the other angles, X and X. That is 180 take away 2X. That's angle AOB. Similarly, if I want to work out angle BOC, you know, in a triangle, all the angles add up to 180 degrees. So if you want to work out this angle BOC, you would do angle BOC plus this Y plus this Y. All these 3 angles would add up to 180 degrees. So 180 take away y, take away y. So I can directly say 180 take away 2y. That's what we are having. Now if you see this AC, that's a straight line. I know when you're looking at the circle, you're looking at the properties and everything, the thing that comes to our mind is that, okay, circle theorem, circle theorem, circle theorem, but avoid using circle theorems. Even while doing this right now, there would be a lot of times when you would be thinking, okay, we might be using circle theorems, but clearly, no, 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 right? So over here, angle BOC and angle AOB, that's what we got. But if you see angle AOC, can you guys text me? Be active on text, right? I'll be asking you questions as well, so that I know that you guys are listening or not. So on your text, tell me, what would be angle AOC? It's a straight line. So what's the angle that is formed on this point O? What would be angle AOC? If you see it over here, it's a straight line. That's what I'm telling you. That's what I'm giving you the hint as. All right, I've received texts. So it's not going to be 180 degrees. I mean, it's not going to be 100 degrees. It would be 180 degrees. Over here, we have 180, and angles on a straight line, that is 180. So the whole of angle AOC, that would be 180, right? But this angle over here, on your angle AOC, if you see a straight line that is being formed, over here, one angle came out to be 180, take away 2x. Other side, I'm getting the angle as 180, take away 2y. Vibhu, very good. You have given me correct answer. Very nice. In descriptive way, you have given me the total that in the center, we will have 180 take away 2x plus 180 take away 2y. And since this is a straight line, the total shall be equal to 180. So 180 plus 180, that is 360. Take away 360 on both the sides, you would get a negative 180 on the other side. So technically, we are getting 2x plus 2y equals 180 degrees. Divide by 2 and you'll be getting x plus y equals 90 degrees. Now if you see your triangle over here, see at point B. At point B, what is angle ABC? Angle ABC is nothing but this x and y. So x plus y is angle ABC, which is equal to 90 degrees. And that's exactly what we had to prove, and that's what exactly we have done over here. I hope this is clear to every one of you out there. Yes? You guys can raise your hand, give me a thumbs up. Says, be active in certain way. Ryan says yes. Abdul, I can see thumbs up. Adwit's thumbs up, I can see. Okay, great, great, great. That's great. All right. Now, moving on to the next one. If you want to write down or if you want to keep taking screenshots and everything, you can. Although this video that you are watching right now, that would be uploaded on YouTube later as well. Alright, so I can see on YouTube now I'm seeing Mothership is there. That's Abdul. Hi Abdul. Okay, I just saw your comments over here, right? So Abdul, if you want, you can join. This is a GCSE live though, of course. But if you want, you can join in the Zoom session if you want to speak up and give answers, Abdul. Right? You can, I think the, what do we say, the link and the passcode and everything is already posted on the comment section. So you can be over there. Alright, now quickly telling you about the courses that we are offering right now. There is this one complete course for the new batch that is going to begin for those of you who are going to sit for the exam in 2024, like 1 year later. In this, we'll be doing every topic in detail. There would be topic-wise revision completely. Then there is this course, rapid course, in which we are going to, for those who are sitting in the exam, for the 2023 exam, it's for those of you. Over here in the rapid course, we are going to quickly go over every topic, and there would be more of like mock test, practice sessions and all of that. That's what we are going to do in rapid courses. They are like quick courses, quick revision courses. And since our exams are almost on our head, so right now we are offering the doubt sessions as well. You can book one-on-one doubt sessions if you want. You can book group doubt sessions, because of course you are practicing math right now. Now for those of you who practice more would know that okay, after every 2 or 3 questions we tend to have doubts and we want to ask our answers, we want to confirm the answers. So in that case, if you have any doubt, you can book doubt sessions as well. Alright, okay. Coming back to circle theorems over here, I told you that there are 9 properties that if you have in your head, you will be able to do the questions of circle theorem, any question. So over here, opposite angles in a cyclic quadrilateral. Now over here, how many of you know what is a cyclic quadrilateral? I would want Advait to speak up actually. Advait, one second. Can you please unmute yourself and speak up what's a cyclic quadrilateral? Okay, speak up. One second, let me just...
Mesh is in a cyclic quadrilateral or quadrilateral that's drawn, let's say, inside a circle where every corner of the quadrilateral touches like the tips of the circle.
Yes, the most important point, a quadrilateral in which all the vertices touch the circumference of the circle. That's what we want to have. Alright, that's important. Right. So over here in a cyclic quadrilateral, we say the opposite angles add up to 180 degrees. Very good, Advait. So over here, B and D, these are the opposite angles. So I would say A plus C is 180 and B plus D, that's equal to 180 degrees. That's what we have. Sorry. Then coming on to the next property, tangents from the same point are the same length. Now this is a property I would say that whenever you're doing questions, we skip this property, we cannot look out this property, it's difficult to judge this property, right? So how can we remember it? With the help of a rhombus. Keep a rhombus in your mind. In any question where there is a rhombus being formed, something like this over here, a kind of a rhombus formed, right? That's where you know that okay, maybe this property is being used. So what do we mean by this? First of all, over here you can do this experiment on your own as well. Draw a circle. Take any point outside the circle and try to draw as many tangents as you can towards that circle. You will notice that from one point you will be able to draw only and only, or not only, exactly 2 tangents. You will not be able to draw more, you will not be able to draw less if I'm drawing the maximum number of tangents, right? So over here, from every external point we can draw 2 tangents, and the 2 tangents that we are drawing, they would be equal. Now if you want to prove them to be equal, you're going to use the concept of congruent triangles. This is a concept. Now what are congruent triangles? When they overlap each other. Like if you see my 2 hands, my 2 hands are completely overlapping each other, right? You cannot see my other hand behind it when I'm overlapping it, right? Similarly, we talk about congruent triangles, and then there are these 4 main properties: SAS, RHS, triple S, AAS. These 4 properties with the help of which you can prove that 2 triangles are congruent. So over here, this is something that those of you who have been taking classes, you already know about it, right? So over here you see these triangles, 2 triangles that we see over here, right? This triangle and this triangle. I've drawn it roughly, right? This is the top triangle that we see, one this side. Now if I mention this name, like let's say A, B, C, and in the center we have O, right? How do I show that these 2 triangles are congruent? You know that there is a right angle over here, right? Because radius is always perpendicular to the tangent. There is a right angle over here. So of course angle OAB equals OCB, which is 90 degrees, right? That's one. Number 2, OA and OC, both of them are the radii, right? So both of them will be equal to each other. Then number 3, OB is a common side which is common in both the triangles. So if you want to overlap them up, of course OB would overlap with itself. So by these three statements, we are saying that I can use the RHS criteria. RHS means right angle, hypotenuse and a side. That's what I'm going to use and say that, okay, the triangles come out to be congruent, right? And if the triangles are congruent, see, if I'm saying that my two hands are congruent, that means they're overlapping each other. That means my forefinger overlaps with my forefinger, my middle finger overlaps with my middle finger. That's obvious, isn't it? If my hands are completely overlapping each other, then corresponding parts will be equal. So over here, this line AB and this line BC, technically we are talking about the tangent, they would also come out to be equal. That's what we mean over here, right? So that means AB equals BC. So AB and BC were nothing but the tangents, right? So that's what we did over here, right? Okay, now coming to the last one, which is alternate segment theorem. Over here, whatever angle is made by the chord and by the tangent. Now you can see there are two segments. Whenever I am over here, Abdul, are you raising your hand? Do you want to ask something? Yes, Abdul, one second, let me just unmute you. Yes, Abdul? Okay, you lowered your hand yourself, alright. I thought you were having a doubt or something. Okay, so over here when we are talking about these, angle made by the chord and the tangent, that's what we were talking about. Whenever I'm drawing a circle and I'm dividing it in two parts, you can easily tell which is the bigger part and the smaller part. So of course this is the major segment and this is the minor segment, right? So if the chord and the tangent, you can see it's in the minor segment that they are making an angle. The same angle would be made in the opposite segment on the other side. This is the major segment. This is the major segment. On the alternate segment, we can say, where we are having that the angle would be equal. So angle made between the chord and tangent, and the same chord subtending an angle. Subtending means you're making an angle like this is my hand, making a certain angle. So just subtend this one side from here, one side from here. That's when we say that we are subtending an angle. So this chord, let's say AB, it's subtending an angle at point C. That's what we mean over here. Coming to the questions part, but before we start with the past year paper questions, as I said, those of you who are taking class for the first time, those of you who are new over here, there are admissions which have been starting for the 2023 to 2024 session, and you guys have to enroll. If you want to enroll, I would tell you the offer that is running at GLECTA currently. So there is 20% off for the first 20 students, right? If you enroll right now, so of course it's a first come first serve basis. If you're the 21st student, so of course there is less chance of having a discount. So if you guys want discounts, this is something that you need to do now, like not right now in the middle of the class, but as soon as the class ends, you can call up our admin team. You see the numbers on the screen as well. So you can call them up and you can just ask them about the details, about schedules, the timings of the classes, the courses that I told you about already, right? So all of those details would be given to you. Okay, coming to the questions now, starting with all the questions. But until now, whatever we have done, does any one of you have any doubts in the theorems that we have discussed so far? Any doubts to anybody? If you guys have doubts, ask your doubts, raise your hand. And if you guys do not have doubts, then there is one simple thing. I'm going to say then if you do not have any doubts, answer my doubts. I have a lot of doubts. I'm not someone who would be like free of doubts in math class, right? In math, it's like we always have doubts. Right, so since nobody is saying a yes, I'm assuming that everything is clear till now to everyone that we have done so far, right? Okay, Abdul raised his hand. Yes, Abdul, speak up. 1 second, let me unmute you from my end. Okay, unmute yourself. Yes, Abdul, speak up. Any doubt?
The circles, I still don't understand them.
Sorry?
I still don't understand it, how to... I don't understand how the circles work.
The circle theorems?
Yeah.
Okay, over here I say that over here we have discussed 9 theorems. Abdul, you're starting this for the first time actually, and you're in year 10. As I said, that this is a session for year 11 kids, although, but that's a great thing if you're, able to do a little bit extra. So I would say that these are the properties that we have discussed, and these properties would be used. In these properties, it's mainly the application part that you would be asked in the exam. Is there any specific circle theorem that you did not understand, or is it the topic that is seeming very, very new to you, Abdul? Yes, Abdul?
It's the topic.
It's the topic, it's the topic. So you would need a little bit practice, go over it one more time, and then once, okay, let's practice the questions, then you would get a hold of it, that how we are applying the questions. I was seeing that Zara was also raising her hand. Yes, Zara? You wanted to speak something, Zara?
No, thanks, sir.
All right, darling.
See, your question is confusing. This class is for year 11 or for year 7?
For year 11, year 11.
But someone is sending a message, but the Nevin
Sorry. This is for the year 11 kids right now that we are doing. So it's for the GCSEs, right? We are doing the grade 7, 8, 9 topics. That is, one of them is circle theorem. So that's what we are doing. All right. So over here, this is what we discussed so far. Now, like I told you that in your exam, you would have questions like, okay, prove that this is not a diameter. I told you for those kinds of questions, we just show that, okay, if QS is not the diameter, then what do we have to show? We have to show that the angle that is formed is not 90 degrees, right? That's it. That's what we have to do. So over here, if I talk about this line QS, what angle is formed at the circumference of the circle? It subtends angle QPS at the circumference. So I need to work out angle QPS. Now it's up to you how we see it. Like I said, the main thing is visualizing how we are applying the circle theorems. I told you, whenever you see that couple name, right, of M and X mixed together like this, which you see over here, we use the property that angles in the same segment are equal, right? So if you want, you can visualize it in this way. Over here, I'm having this arc QR is subtending angle QSR. That's one angle that we have. And similarly, it subtends angle QPR. So if you see this yellow part that I have highlighted, over here, these two angles that are formed inside over here, in that M thing that I told you about, right? So these two angles would be equal. That means this angle comes out to be 27 degrees. See, to show that QS is not a diameter, I need to work out angle QPS. I have found out QPX, but now I'll be working out angle XPS as well. What about this? Now if you see triangle XPS, it's clearly given that this is an isosceles triangle. An isosceles triangle. These dashes represent that this is an isosceles triangle. What would be the missing angle over here? This angle. So all you got to do is 180 take away 50 divided by 2. Whenever we have to figure out the missing angle of an isosceles triangle, we do 180 take away the given angle divided by 2. Why divided by 2? Because these angles are equal, right? So you're adding it twice. So of course you would have to divide by 2 when you're finding out the missing angle. So 180 take away 50, that is 130. 130 divided by 2, that comes out to be 65 degrees. So what is the total angle QPS that we are getting? 27 plus 65, which comes out to be 92 degrees, not 90. That's all I needed. I did not want the angle to be 90 degrees, and that's all we got, right? So we got that this angle is 92 degrees. So that means if this is not 90, that means this is not a diameter. That's what we have over here. All right. I hope this is clear to every one of you out there. Yes? Say a yes or no, guys. You can unmute yourself and speak a yes or a no, and you can let me know that you're understanding or not. Okay. I can see you guys texting me. Advit says, yeah, miss. Advait, you were saying that you had to go to the gym. What happened to the gym thing? You can unmute yourself if you want to speak up. You can unmute yourself. Advait says didn't go. Yeah, great. By the way, it's Advait's birthday, everyone. So everyone should wish Advait a very happy birthday. Yes, Advait? And your birthday is actually coming up very soon, I would say. But let's start wishing him. Isn't it, Advait? I would not ask on the YouTube live session that everyone should sing a song for Advait. No, but I'll do it in the class otherwise. You know that your classmates would be singing a song for you very, very soon. Okay. Coming back to the circle theorems part over here that we had been discussing so far. Coming to the next question. Now this one is an interesting one, unlike a 4 or 5 mark kind of a question. If I want to work out angle ODC. Now, visualize what kind of circle theorems are being used. You see a rhombus. This time I do not have that couple name for M and X, right? I don't have this thing. So of course I'm not going to use angles in the same segment. But you see a rhombus being formed over here, right? This is a kind of a rhombus. So I told you you would be using your tangent properties, right? That means AD and DB. These two tangents would be equal in length. If these two tangents are equal, if I'm drawing the chord DB, I tried to draw a straight line at least, but yeah, then this angle would be equal to this angle, like at point D and at point B that I have marked, because this forms an isosceles triangle, ADB. See, I'm going to do all my calculations in the diagram itself, so try to understand it from the diagram itself, and if you want to write it down, you can make notes simultaneously. So over here, I have figured out, okay, what would be these angles over here. In an isosceles triangle, I just told you if you have to find out the missing angle, you can do 180, take away the given angle divided by 2. This would come out to be 70 degrees, right? That's what we have. Then, this is also 70. Now, there is an L being formed over here. If you see very closely, OB. OB is the radius and BE. That's the tangent line, right? The angle that is formed between radius and tangent, 90 degrees, right? So this total, like angle OBE, should be equal to 90 degrees. If the total of angle is 90 degrees, I'm just putting my pen over here. I'm saying the total angle, the L angle that we are forming, that is 90 degrees. So of course this angle formed between my forefinger and this pen and between my thumb and the pen, right? That would also add up to 90 degrees. So technically 75 plus angle OBC, that should be 90. So that means this comes out to be 15 degrees. That means this missing angle on the other side, this would be 20 degrees, right? That's one thing that we have over here. Similarly, I can say because OD is the radius and OB is also the radius, right? Mothership is on YouTube over there. That's Abdul. That's there on YouTube as well. And Abdul is wishing Advait a very, very happy birthday. So Advait, happy birthday from Abdul. That's a year 6 kid that is wishing you a happy birthday. Okay. So over here, then after this one, we have angle BDO. That would also be 20 degrees, right? An isosceles triangle being formed because it's OD is the radius, OB is the radius, right? So this is the angle that is formed. Now I want you guys to tell me what would be angle at the center, or technically we do not need the angle now. It's up to you how you are going to use your circle theorems. There are various ways of attempting this question, various ways, various theorems that can be used. I can use that angle in the center is like the angle at the center is double the angle at the circumference, or we can also use alternate segment theorem. Alternate segment theorem is sometimes, I would say, difficult to visualize. So you would have to practice a lot of questions to be able to visualize it, right? If you want, you can directly say from here, OBE. OB is the, sorry, not OBE. CBE. CB is a chord, right? BE is the tangent. Angle made between the chord and the tangent, this angle, 75 degrees, would be same as the angle that is subtended on the other side. So this total of angle D over here, this total shall be 75 degrees. So you can say angle CBE equals angle BDC. That's the alternate segment theorem that I'm using. Again, telling you how to visualize it. We have a small circle over here, not small, like I'm just drawing it for your help. We have a circle, we have this chord, we have this tangent. So whatever angle is made over here with the chord and the tangent, this green angle, that's same as when I subtend this chord on any other side, on any point on the circumference on the other side. This green angle, these two green angles would be equal. So let me highlight it for you guys so it becomes easy for you to understand. I'm saying CB as a chord and it is subtending this angle. This is a past year paper question, an important one. So I hope you're understanding it very, very carefully. So over here at point D, angle BDC, that would be a total of 75 degrees. So if I'm saying angle BDC is 75, you have to work out angle ODC, right? You see two angles. BDC comprises of two angles. This 20 degrees, which is on the inside, and angle ODC, which is over here, the red angle that is marked over here, or now technically the green angle, right? This would add up to 75 degrees. That's what we are saying, right? Let me just remove the annotations of the previous calculations. Yes. So now you can subtract 20 on both the side and you would get the angle ODC as 75, take away 20, which comes out to be 55 degrees. Like I told you, these kinds of questions come for like straight for 4 marks or 5 marks. Past year paper question, an important one. So I hope this is clear to every one of you. Yep. Thumbs up. Anybody has any doubts, you can raise your hand. I'll go over it again. I do not mind doing that. I hope this is clear, right? This was a little bit of circle theorems that we discussed. After this, we would be having perpendicular lines as well. Again, telling you, since your exams are on your head in your May, June, your exams would be starting very soon, right? So there, if you want, you can get your doubt sessions, book your doubt sessions as well. You know that in your April, your holiday time period, you can utilize your holiday time period, get yourself, like either get booked with the doubt sessions, ask your doubts if you have any particular topic, any particular question, or the entire chapter if you want to revise that way. Or you can also go for the rapid courses that would be launched during that time period. You can contact the admin team, the numbers that you see on the screen that are there already, right? You see the website as well over here behind me. So you would be able to contact any one of them and you will have the information that you want for the rapid courses or anything. All right. Coming to next, perpendicular lines. Okay. What are perpendicular lines? Like a very basic and easy question that I'm asking. What are perpendicular lines? Anybody? You guys can type in as well. Come on. Okay, Abdul raised his hand. But Abdul, I would not want you to give all the answers. I know that Abdul already knows. He has already done perpendicular lines with me already. Yes. So what about the others? Anybody else? Jaden, can you hear us? Okay, Jaden has texted when two lines intersect at a right angle. Yes, very good. So when two lines intersect each other at a 90 degrees angle, that's when we say perpendicular lines. Now this is a topic of grade 9 again, where you could be asked to find out the equation of a perpendicular line. Now what's the relationship between the gradients? That's the important part to understand. Whenever we write our equation of a straight line, it's always in the form y equals mx plus c. This m is the multiple of x. This multiple of x is the gradient over here. Now what is the relationship between gradients of two perpendicular lines? If I'm saying that one line has gradient m, then the other line should be having gradient in such a way that it is the negative reciprocal. If you want, you guys can note it down. It's the negative reciprocal of the gradient of the first line. Negative reciprocal means, reciprocal is when you flip the fraction. Like if I say y equals 2 over 3x plus 10. Along with x, what is getting multiplied? 2 over 3. So if I'm writing the equation of a line which is perpendicular, flip it and take negative of it. So negative 3 over 2. 2 over 3 becomes 3 over 2. X and along with the negative sign. Plus you can write anything, plus 100, minus 200, anything. So plus c. That would depend on question to question where you are solving it. So the condition would be particularly given to you in the question and accordingly you will have to solve it. Right? That's what we do. Okay, then coming to the next one. Again, an exam question, a past year paper question for 4 marks. Now, it's not like that they are going to just directly say, okay, find out the equation of a perpendicular line. If they were giving you easy questions like that, oh, life would be so easy. But they would give you questions in a mixed form where you would be applying the concepts of other topics as well. Like in this one, ABCD is given to be a rhombus and the coordinates of A are given as 5, 11, right? They are asking me to calculate the equation of AC when they have given you the equation of diagonal DB. Now a simple property that I'm going to use, diagonals of a rhombus intersect each other at 90 degrees. Now see, if you are not able to think of this property in the exams, then it would get difficult to think of it like, okay, what concept are we going to do? What should we do to find out the equation, right? Now if I have told you this first statement, now it of course becomes easy. You know how to find out the equation of a line which is perpendicular, right? So now let's do it. If I want to work out this over here, for DB, the equation is y equals a half of x plus 6. What is getting multiplied by x? I see a half. So to find out the equation of a line which is perpendicular, that is for AC, all you got to do is flip, negative reciprocal, negative flipping. So 1 over 2 would become 2 over 1. Anything divided by 1 is the number itself, like any number divided by 1, it's the same. And then I would write a negative sign in front of it. Y equals mx plus c. I have figured out what would be m. It is the negative reciprocal. Whenever I'm asking you the equation of something, you need two things, m and c. So over here now to find out c, substitute whatever coordinates are given. Your coordinates are always in the form x comma y. So we put in x equals to 5, y equals to 11. That's what we are going to do. So 11 equals minus 2 times 5 plus c. So 11 equals negative 10 plus c. C comes out to be equal to 21. That's the equation that I'm having. Just put it back in. So my equation becomes y equals negative 2x plus 21. This is what we are having. That's it. And we got our answer. So that's the equation of AC that we got. That's about perpendicular lines. Now why did we study circle theorems and perpendicular lines together? Because it forms a questions of equations of tangents, right? Which I would be taking up in other live sessions and we would be discussing more about it. So I would say that this was all for today. I would want you to take a screenshot. This is also a past year paper question. And I want you guys to try it out on your own. And I'm giving you some homework questions, the questions that you see on the screen. Later on, of course, the video would be uploaded. So you can view these questions, pause and easily just, try these out. This is like a 5 marks question and a pretty interesting one. If you have doubts, book your doubts session and you can ask me any of the questions. And as I said, over here, if you have younger siblings, if you have older siblings, right, for older siblings, we have the courses for A levels, year 12, year 13 courses that we have over here. If you have younger siblings who are preparing for 11 plus exams, there are classes available for them as well. Basically, you name any level and we have it over here. So in case you want to take up any classes, you see the numbers on the screen, you can contact them. Okay. Apart from that, you can also let me know in the comment section later on that a particular topic that you would be, you would want me to take up in the live classes. Muzi asked, how do you book a doubt session? Darling, you see the numbers on the screen, like behind me also you see the WhatsApp numbers and you see the website, the information, you see it running on the contact details, you see it running on the screen. So that's where you can contact, alright, and you'll be able to book a live session and everything. And as you have your GCSE exams very soon, so we'll be holding back-to-back live sessions of all the subjects, not just of math, like for chemistry. Those of you who are there, I want each and every one of you to be there on next Saturday as well for your chemistry live class, which is on 18th of March and same time 11 o'clock. So be there and revise your particular topics, the topics that we would be doing, and of course not we as in me. I'm not going to be taking up chemistry anytime soon. No, I'm really very bad at chemistry, so I would be sitting along your side. We'll be taking up the chemistry lesson from the chemistry teacher. I would not be teaching although. Yeah, but for the chemistry session, these are your details, 18th March, 11 o'clock. So you have to be there. Alright, your chemistry teacher would otherwise ask me that, okay, the students who came in the math live class, why were they not there in the chemistry live class? So you definitely have to be there. And I want all of you guys to subscribe to our YouTube channel as well. There are these shorts and everything, we provide contents for like the basic facts as well, the Instagram reels. So just do not scroll Instagram for random reels, right? Have some knowledgeable content as well on your social media. So I would want you guys to add GLECTA on all the social media platforms, the YouTube channel. There would be live sessions like I told you, and even this live session would be uploaded on the channel. So in case you miss out any notification from our team or by any chance, you would have if you have subscribed to our channel, you'll automatically get notified that okay, there is a live session coming up, and you would be posted about every live session, every detail, everything, right? I hope everybody understood everything that we did today, and if you have any doubts in any topic, like I told, if you want me to take up circle theorems, algebra, completing the square, these are like grade 9 topics that I would be focusing more towards. But if you have any other topic as well, you can let me know, right? One second, I'm receiving chats. So do we have TikTok? We would be there on TikTok very, very soon. So Advit says that he has bio. Don't worry, you can tell your bio teacher that you were there in the math session, so she'll understand. Not a problem with that, Advit. And anyway, we have just winded up very soon. All right. So everybody, thank you for joining us today, and I'll see you guys in the next live session. And I'm going to ask you if you have subscribed to the YouTube channel or not. So definitely. Also, let me know in the comment section on the YouTube video side where you see. Let me know in the comment section in which particular topics you're facing problem, so that in the next live session I can take up those particular topics. Alright. Okay, so that would be all for today. Bye-bye everyone, and have a great, great, great weekend. I'll see you guys in the next live session, not of chemistry, in next math live session. Bye-bye everyone. Thank you for joining.